Example 1, guys, says, for the tables below, state whether it is an arithmetic sequence, okay, which is linear, or a geometric sequence, or neither. If it is an arithmetic sequence, I would like for you to find the d value. If it's geometric, then find the ratio, okay? So that's what I would like for you to do for A, B, C, D. And then make sure you guys check with the key or check with your friends, okay? And then if you are struggling with identifying what type of sequence it is, please come and seek help in office hours, okay? All right, so we have some definitions here. The first definition is exponential function, which is an equation in the form of y equals b to the x power, where b is the base, such as your base, we would like for it to be bigger than 0, but never equal to 1. And x is the exponent. You are going to have an exponential growth equation when your graph is increasing, okay? And then exponential decay is an exponential graph that is, copy and paste went wrong. Decay, could you please fix this to decreases, okay? The graph that decreases. And we study asymptotes already, guys, but this is a review here. An asymptote is a line that the graph of the function approaches, okay? Feel free to hit pause to finish copying that down. Let's look at our very first parent function here. You're gonna see lots and lots of different parent function depending on the base, okay? And the normal typical form is going to be a times b to the x. Now, for the parent, your a is going to be 1. So for the parent, we're normally going to see a equals 1. So that means it's going to be y equals b to the x. You're not going to have an a that's not 1. You're not going to have an h value. You're not going to have a k value. That's why it is going to be y equals b to the x. It's a growth 1 if your b value, which is your base, bigger than 1, okay? So our very first parent function equation is going to be y equals 1 times 2 to the x power. But guys, 1 times 2 to the x is the same thing as y equals 2 to the x. And I have a table here that we can just fill in. Y equals, remember, this 1 times anything is itself. So it's kind of like just 2 to the negative 2 equals 1 over 4. Then 2 to the negative 1 equals 1/2. 2 to the 0, students, is going to be 1. 2 to the 1 is going to be 2. And 2 to the second, that will give us 4. Let's plot this out. Negative 2 up 1/4. Negative 1 up 1/2. 0 up 1. 1 up 2, and then 2, 2, 4 up 4. Notice how it doesn't matter what x value we pick. We could never get a y value that's going to be 0. So that creates an asymptote like this. This is your horizontal asymptote, HA, and that's going to be at y equals to 0. So our graph, students, it's going to get closer and closer to the asymptote. Don't touch the asymptote because we can't really get y equals to 0, and it shoots upward. Since your b value is bigger than 1, this is increasing since it is growing, okay? So that's going to say, oh, increase or decrease. We want to say increase right there. And it's increase from negative infinity to positive infinity, because that's also the domain of our exponential graph here. Now, if you like to write all real numbers, we will also accept that. Your range is bigger than, y is bigger than 0. And now sometimes we write it like this, 0 to infinity, okay? We don't have an x-intercept here. As you can see, it never touches the x-axis since there's an asymptote there. And your y-intercept is 0, 1. We don't have a vertical, but we do have a horizontal asymptote at y equals to 0. Now, case number 2, we are going to deal with a decay graph, okay? Now, a decay graph is going to have a base in between 0 and 1. So that's going to give us this one, y equals 1 times 1/2 to the x power. But guys, 1 times anything, it's itself. So another way to write this is y equals 1/2 to the power of x, just like that. So let's plug in some values. Similarly, we're picking -2, -1, 0, 1, and 2. So when we have 1/2 students raised to a -2, that is identical to 2/1 raised to a power of 2, and that's going to give us 4. And then 1/2 raised to a power of -1, that's the same thing as saying 2/1 raised to a power of 1, which is 2. Any number raised to a 0 power, students, is always 1. 1/2 raised to 1 power is 1/2. And 1/2 raised to the 2nd power is now 1/4. We, again, can't really get a y value that's going to turn out to be 0. So that will give us a horizontal asymptote here at y equals to 0. Let's plot all of our dots here. -2 up 4, -1 up 2, 0, 1. We still have the same y-intercept point. Doesn't matter what parent function we have. Okay, 1 up 1/2, and then 2 is 1/4. So that is going to give us this exponential function, but as you can see, it starts high and it goes lower and lower and lower. Hence, that's going to be a decreasing function because it's a decay. Our b value, guys, is between 1 and 0. Excuse me, 0 and 1. So that's why it's decreasing. Excuse me, guys. Okay, so it's going to decrease over its entire domain. And if you're writing it as an interval notation, make sure the smaller number, comma, larger number, or all real numbers will also be just fine. The range value is y is going to be bigger than 0 or 0 to infinity. Note, we don't have any x-intercept. Doesn't matter if your parent function is decaying or growing, okay? Y-intercept is the same as the growth. Vertical asymptote is going to be NA, guys, but the horizontal for the parent is going to be y equals to 0. Let's pinch that in. Now, I know that your table, it's below the graph. I kind of move it to the side so you can see it together, but feel free to fill that out, okay? Under here it says, note, the exponential decay, again, just a reminder, okay? Decay model can be written as y equals a times b to the x, where your base is in between 0 and 1, or y equals b to the negative x. The reason that's the same is, guys, remember, y equals b to the negative x. To make this negative power positive, remember, we move it to the bottom, 1 over b, and then change the positive exponent. So that's why it's the same thing. So if we're using a negative power, then as you can see, negative power means your base is going to be bigger than 1, okay? But usually we write it as a fraction that's going to be in between 0 and 1. State number 2. State each equation below as growth or decay function, okay? Remember, pay attention to the exponent as well. So for this one right here, your base is 2, okay? b equals 2, which is definitely bigger than 1, but your exponent is negative. So that brings us to this little dude, right? Because your exponent is negative and your b is bigger than 1, this is going to be a decay graph. Try b on your own, and then c sets y equals 0.1 to the x power. Your exponent here is positive exponent. So that means since your b value is going to be 0.1, which is in between 0 and 1, and this having a positive exponent, guys, that brings us to this guy right here. So if that's the case, since b is not bigger than 1 and x power is positive x, this is also a decay. Okay, so c is also decay. I want you to do b on your own, on b, okay? Now d says y equals 1/10 Now, from the first glance, we can see that b is 1 over 10, and some of us are going to say, b is in between 0 and 1, so I'm just going to write decay. Well, that's not necessarily true. We also have to look at the exponent. The exponent is going to be negative. So what that means, guys, to make it a positive exponent, we are going to switch, or I would say take the reciprocal of the inside. Well, inside is 1/10, so reciprocal of that's 10 over 1, and now we will have a positive exponent. Since it's a positive exponent, and your b is 10, which is really bigger than 1, so this is a growth graph. So you have to look at both, okay? Your base and your exponent. Okay, so this is a little spill here on your parent function. Graphing exponential functions of the form y equals a times b to the x. When h, k, they're both going to be 0, okay? Your a value represents the initial value, the value of y when x is 0. B represents the growth if b is bigger than 1. Remember, assuming your x power is positive. And decay if b is in between 0 and 1. And again, this is when we're talking about the exponent of x being positive. Okay. So with that statement, y equals a times b to the x. Can you tell me, now look at the graphs again, okay? Can you see here's when we have a decay and here's we have a growth? Can you write a couple of sentences to compare that with your y equals a plus bx, which is the same thing as y equals mx plus b, which is a linear, okay? This is your linear. This is the same, okay? All right, give me a couple bullet points if you want to, or complete sentences in a paragraph form.